Arches are curved structural elements used to span openings like doors, bridges, or windows. Unlike beams, they don't resist loads by bending. They carry loads through compression along their curved shape. To build an arch, we place wedge-shaped blocks called voussoirs in a curved pattern. The central one is the keystone. Once it's placed, the arch locks into position and can carry loads. When a load is applied to the arch, it gets transferred along the curve, creating compression forces inside the arch. That's why arches are mostly made from stone or brick, materials strong in compression. But here's the catch: that compression creates an outward push at the base called thrust. To resist this thrust, we need strong supports at the ends called abatements or tie rods to hold the arch in place. That's how arches stay strong and stable under heavy loads. Now, let's study the parts of arches in detail. Let's start with the abutments. The abutment is the end support of an arch. It's the portion of the wall that firmly holds the weight and thrust of the arch. Without the abutment, the arch wouldn't have the stability it needs. Just like shoulders carry the weight of a beam, the abutments are the strong shoulders of the arch. 2. Arch ring. The arch ring, also called ring or rim course, is the entire curved course of the arch, made up of voussoirs. An arch may consist of a single ring or multiple rings for added strength. This is the visible curve we admire. It's what gives arches their timeless aesthetic and structural value. 3. Voussoirs. These are the wedge-shaped blocks that form the body of the arch. I have marked 1, 2, 3, etc. Each voussoir is perfectly angled to transfer loads down to the supports. 4. Key or keystone. Also called as capsule stone, is a wedge-shaped stone at the apex of an arch, and it is the last piece placed in construction. It locks all the stones of the arch so that it can bear the entire weight of the arch. The keystone is like the cherry on top, but structurally, it's what makes the arch whole and stable. Without it, the entire arch would collapse. 5. Skewback. Skewback forms the inclined or splayed surface on the abutment from which the arch springs. It is a surface against which the end of an arch rests by means of the portion of support. On this support lies first voussoir of the arch is placed. Talking about this, we will learn the first voussoir of the arch ring. Here it is number 1, and number 20 is called the springer. Resting on the skewback is the springer, the first wedge-shaped stone or brick or voussoir. It's the starting point of the actual arch curve. 7. Springing points. These are the specific points on either side of an arch where the curve begins. Every arch has 2 springing points, one at each end of the base of the arch. 8. Springing line. This is an imaginary horizontal line that connects the 2 springing points of the arch. Now, the springer I defined before can also be interpreted in different but related ways, and can be asked interchangeably in competitive exams. It can refer to the voussoir located directly at the springing point of an arch. Or, it is also defined as the first voussoir at the base or springing level of the arch. These terms are closely related and often cause confusion in technical and competitive examinations. Be sure to understand the context in which the term is used. Now, the 9th part is intrados and extrados. If you look at the arch ring, the intrados is the inner curve, the visible underside of the arch, while the extrados is the outer curve, where external loads act first. But these aren't just names. They help engineers understand how the load travels through the arch, and they're key to calculating thrust, curvature, and stress zones. So when designing or analyzing an arch, knowing your intrados and extrados is more than theory. It's essential to structural stability. Now, having this known, we move to the 10th part, the crown. At the highest point of the arch's curve is the crown. It's where the extrados peaks, usually right above the keystone. 11. Soffit. A soffit is the underside of a part of a building, like a protective covering under the surface of an arch or under the eaves of a house. Imagine walking under a grand stone archway. The curved ceiling above you is the soffit. Before we move on to the next part, if you're enjoying this deep dive into the components of arches, don't forget to hit that subscribe button. It's a great way to stay updated with more content like this, and it helps support the channel. Now, let's keep going. 12. Haunch. Haunch forms the lower half of the arch between the crown and the skewback or springer. It carries a significant portion of the load, especially in wider arches. Now, imagine multiple arches placed side by side in a row. This arrangement is known as arcades, which is the 13th term in the parts of an arch. Arcades are a row of arches in continuation or succession that are supported on piers or columns and carry a wall over it. As shown in a series of arches are constructed and supported intermediately by columns or piers, and at the end it is supported by abutments. So, we move to the 14th part, which is pier. Piers are the intermediate supports of a row of arches. The arcades. 15. Spandrel. Spandrel is the space between the extrados and the horizontal line through the crown. It forms a curved, triangular space. 16. Impost. When the skewback is horizontal, we sometimes need an extra element to carry the arch. This is the impost, a projecting course placed on top of the abutment, usually made of stone or concrete. Now that we've seen all the parts that make up an arch, let's dive into some technical specifications used in the design and analysis of arches. 16. Span. The span is the clear horizontal distance between two supports of the arch, either between abutments or piers. Just like stretching a string from one end to the other, the span tells us how wide the arch opens. 17. Rise. The rise is the vertical distance from the springing line to the highest point of the intrados. It defines how tall the arch appears from its base to the curve inside. The higher the rise, the more dramatic and elegant the arch looks. 18. Center of the arch. The center or striking point of the arch is the geometric center from which the arch's curve is struck, particularly in circular or segmental arches. In drawing and design, this is your compass point, guiding the perfect arc. 19. Depth or height of arch. This is the vertical distance between the intrados and the extrados. It tells us the thickness of the arch curve vertically. It's like measuring the arch's body from top to bottom, not just its face. 20. Thickness or breadth of soffit. The thickness or breadth of soffit is the horizontal distance measured perpendicular to the front and back faces of the arch. Think of this as the width of the arch if you cut a slice of it. 21. Bed joint. These are the joints between each voussoir that help hold them together. They're slightly angled and shaped to transfer force down the arch. Every brick has its place, and every joint ensures it stays there, safely. This wraps up our detailed breakdown of the parts and specifications of arches. Understanding these elements isn't just about passing exams. It's about applying this knowledge in real-world projects. So next time you see an arch, remember these parts and appreciate the engineering behind it. And hey, if you found this breakdown helpful, consider hitting that subscribe button. It helps keep this channel going and brings more content like this your way. Thanks for watching.